This ad hoc lab is like throwing you in the deep end of the pool. So far, we've only talked about the concepts of IPv6 addresses. Now I'm going to give you a few commands, give you some instructions, and let you try them for yourself. Well, let's jump in. We'll use this topology with 4 routers. R1 has 4 interfaces. The other 3 are like branch office routers with only 2 interfaces. The packet tracer file comes with everything to do with IP version 6 pre-configured except the global Unicast addresses on the interfaces. That's your job. Now, what values to use? Well, use this table. Now, it looks a bit like an eye chart, right? But router R1 has those 4 interfaces, so you get into interface config mode on gig 00, configure this address. Gig 000, address. Gig 010, this address, and so on. For perspective, this right-hand column gives you the fully expanded address, so you can see things like, by convention, I used 15 zeros and a single non-zero digit at the end and the interface ID, with that last digit being the router number. It's a lab just to make the numbering pretty simple, and you can configure those abbreviated numbers when you use the configuration command. All right, so here's basically the list of tasks for the lab. Before you configure anything, I want you to predict all the prefix IDs that should occur on the router based on the configuration of those interface IPv6 addresses, and predict what connected routes will exist on each router. Once you've done that on paper, then get into Packet Tracer, open things up, and use this interface subcommand, IPv6 address, followed by the address / and prefix links with no spaces, and that configures the address on the respective interface. Once you do that for all 4 routers on all the interfaces in the table, you've completed the configuration part of the lab. Then I want you to look at the routes. Use the show IPv6 route exec command, and there'll be a code in the far left like there is with the show IP route command, and look for connected routes that have a code C and OSPF routes with a code O. You can ignore local routes with a code L. So look at that, think about those, and think about those addresses and prefix IDs. I'll give you a few seconds to hit pause and go do the lab, and then I'll give you a walkthrough of the lab exercise. To begin the lab walkthrough, let's make our predictions about the prefixes or the subnets. I've got them listed around the diagram. Over here on the left, notice all of the prefixes and all the addresses begin with the same first 12 hex digits, unabbreviated. So abbreviated, they all begin 3 fox 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 :1 fox. Then the 4th quartet's where the subnet field exists, and this is subnet 1. On the 3 WAN links, we've got subnets 12, 13, and 14. And on the right, we've got 3 more subnets, subnets 2 off of router 2, subnet 3 off of router 3, and subnet 4 off of router 4. So that's where you should see the subnets. Or if you prefer, here's a table. You can hit pause and review this. The addresses and the prefix IDs are nearly identical. The prefix IDs basically zero out the interface ID, and the interface ID was mostly zeros already, so they just all end in double colon here for each entry in the table. So for router R1, focusing on it, it's got 4 interfaces, so it should have directly connected routes for 4 subnets, the 4 that you see here. Routes for the other subnets on the far right should be OSPF learned routes. Let's take a look and see if that's what happened. So here's our topology in Packet Tracer, and we'll start with router R1 and open it up. And I've already configured all the IPv6 addresses in this Packet Tracer file, but just to show you how to do it in case it's unclear, get into config mode, get into the interface mode you want to configure, like interface gigabit 0/0. And if you type the IPv6 address command and do a question mark, it's asking for the IPv6 prefix and prefix links there. And if you look at the list from back in the video, see if I can do this from memory, 3 fox 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 :1 fox :1 :1. Yeah, it's nice and loud to be able to follow a nice easy pattern. And there you go. That's how you configure the address. And we go to gig 000 was that first WAN interface, and that was attached to subnet 12. By the way, I did the up arrow to retrieve commands and then left arrow to move back. And I changed that subnet ID portion, that fourth quartet, to 12 and did that. 2 up arrows, 2 left arrows, change it to gig 1010. 2 up arrows, a few left arrows to change it to 13. So I can go pretty quick just because I've done it a jillion times at this point and just to complete the task. But I've done this on all 4 of the routers prior to starting the recording. But there's what you would do to do the configurations. So now we want to check out the connected routes and the OSPF learned routes. So if we look further, show IPv6, show spelled correctly. And we see this legend at the top of all the short codes, and we've got C for connected and L for local. And then where to go? O for OSPF intra area. And those are the codes we see out here on the left. So I said ignore the local routes, but we should see connected routes for subnet 1, as you see here, connected route for subnet 12, connected route for subnet 13, and a connected route for subnet 14, just as we described with the PowerPoint slides. Then there are 3 remote subnets from R1. Those are learned with OSPF because of some config you didn't do that I did ahead of time, the 3 remote LAN subnets of subnet 2, subnet 3, and subnet 4 there. All right, so that's what you should have seen looking around here on router R1. And next we'll take a look at router R2. With router R2, it has that one right-hand LAN interface connected to subnet 2, and it's one WAN interface connected back to router R1 connected to subnet 12, so it should have 2 connected subnets, with the other 5 subnets showing up as OSPF routes. Let's see if that's what it shows in the routing table. All right, drilling down on router R2, I've pre-configured the addresses, so this time let me just show you what we see in the show running config output. Scrolling down a bit, we've got the gig 00 interface, where I've configured that command before I started recording. That's for subnet 2 there. And then down a little further, we've got the subnet 12 address there on the WAN interface of gig 000. They're pre-configured. And by the way, this command confirms those addresses as well in short form there and there. But we're mostly focused on configuring those addresses and looking at the prefixes that appear in the routing table. Now in real life, you would really want to try a show IPv6 route connected to see the connected routes only, but Packet Tracer doesn't support it. Or show IPv6 route OSPF to see just the OSPF routes. Hey, what do you know? Looks like that one's supported here. So we do see 5 OSPF routes in the show IPv6 route OSPF command. So what are they? We see, quote, subnet 1 here. That's the LAN subnet off router R1. Subnet 3, the LAN subnet off of router R3. Subnet 4, the LAN subnet off router R4. And then the other 2 WAN subnets that aren't directly connected here to router R2. Subnets 13 and 14, if you will. So you can get a closer look at just the OSPF routes here. But if you want to look at those connected routes, remember show IPv6 route connected doesn't support it. So if we just do show IPv6 route and sift through it, here's a connected route for subnet 2. That's the local LAN subnet off of router 2. And here's the WAN subnet connected off of gigabit 000 off of router R2 as well. So those are those 7 subnets we remember from that topology diagram. Now let's take a look at router R3. Again, it should have 2 connected subnets and 5 remote OSPF learned routes for those subnets. So if we look a little closer, show IPv6 route connected, not supported. Same thing with OSPF. We see those 5 OSPF routes. So picturing R3 in the topology, it's connected to 2 subnets. The other 5 are remote. What are they? We've got subnet 1 here, subnet 2 off of router R2, subnet 4 off of router R4, and then the two WAN subnets, subnet 12 and 14, that were the top WAN link and the bottom WAN link in the diagram. If you want to see the connected routes, you do the full command output and just search around for those connected routes like the one to subnet 3, which is the LAN subnet out to the right of router R3, and subnet 14, the WAN subnet between router R3. Whoops, sorry, that's not it. The WAN subnet between router R3 and router R1 off of local port gig 000. And just so you can see the interface is configured, show run, and scroll down a bit. Here we see the interface subcommand under gig 00, and same deal here under gig 000. Now for R4, you probably feel like it's getting a little repetitive, so I'll leave that as an exercise for you to do the verification there on R4, which should also have 2 connected IPv6 routes and 5 OSPF learned routes. Hope you enjoyed trying out these commands and looking at the prefixes and getting used to the command line interface a little bit with these labs. Hopefully it was intuitive and you connected that to the theoretical. Hey, if you're new, of course, subscribe and click the bell. Great hanging out with you. Talk to you soon.